Hello. Yeah. So we are going to talk about how you can secure AI workloads using zero trust security. So yeah, I'm Rohit, and I work as a like consultant kind of a person who works for the DevRel service and providing services to the cloud native companies, right? So we don't have a journal here today. He couldn't make it because of some visa restrictions and all. But yeah, Vinuja.
Yeah, hi everyone, I'm Shivai. I am a developer experience engineer at Couchbase, and I have been pretty much working in the AI field for the past 7 years. Started off with a lot of hackathon projects, but and then building my own company as well. So of course, we are really excited to be talking more about how you can involve best practices for security, by also giving you some reference architectures that we have implemented at our own companies using mostly open source technologies as well. So looking forward to the panel.
Hello everyone, myself Vinuja Khatode. I'm a DevOps engineer at Tune AI, and I've been managing a platform which deploys LLMs and AI workloads. And this is my very first panel here, so I'm quite nervous over here, so bear me.
Yeah, so actually, this is kind of an extension to a panel we watched yesterday about security in AI, and so Divya was the moderator for that. So, and also in the morning we saw the AI technologist panel with Amanda moderating it, right? So we are seeing like there's a lot of talking about AI and models, open source models like DeepSeek, Mistral, Llama, and everything, right? But when we are working with this model, so how we can provide the security to it, like because it is one of the biggest concern in the companies working all over the world, right? So I will go depth into that, but just wanted to introduce like what we will be talking about. So this is kind of a agenda for us today, and this I guess everyone knows, but yeah, like AI is a broad spectrum, and inside that it works on the intelligent machines and stuff, and then you have like machine learning, which is another subset of it, but here you have to put on data and then train it, and that's how it will work as a like human kind of a form. And then deep learning is another like I will say specialized subset kind of a thing, where you use neural networks to work inside that, and you can perform a lot of activities around it. And so LLMs is nothing but the you can say it is the another subset of deep learning, but not completely, because it makes like makes models to understand human language. So you have heard about NLP, which was one of the subjects in the computer science, right? So this kind of same kind of a form of LLMs today, and so yeah, there you learned about n-gram models and stuff, right? So I was working like 2-3 years back in machine learning field. So there I worked with n-gram, LLM, PTZ and stuff. So 4 years back, trust me, like no one was that much like kind of excited about LLMs as they have today. So yeah, like why they are, we will see. So you must have gone through a lot of tweets nowadays, right? Everyone talking about DeepSeek and need of NVIDIA GPUs and all. Like people are just tweeting like anyone has a H100 GPUs, please provide us. So there are some companies who provide it for like you can say subscription method or free reward stuff, right? So another thing is like we saw after DeepSeek was launched like 10, 11 days back, right? You can just run like R1 reasoning of DeepSeek by using 4 or 5 M4 minis. So this is really revolutionary. Like when I was running small LLM models like 5 years back, we have to connect to the company server using TeamViewer and handle the data servers directly. So this is fun. And similarly, for this is the graph which shows about how everything is going on around need of GPUs and how all of the GPUs are compared and all. So without wasting time, I will like to ask Vinuja, like you have worked in the deployment side of LLMs in the Tune AI, right? So can you share some insights about it?
Yeah, sure. So deploying LLMs is one of the tasks where the decision has to be made on depending on multiple factors, considering what exactly the requirement is, what scalability needs we have, and then constraints such as cost and security, and mainly data security. There are actually multiple ways, different ways to deploy LLMs, and the easiest way is to get the cloud managed APIs, where we do not have to do anything, just select the model which we want and then get the API from that. But do we know where our data is stored when we are using that model? This is such a big security question. Then to prevent that, we can either use, there are other methods that has using VMs and GPUs and then deploying and training our own model over there. But again, it's cloud. We do not know where our data is. And also there was a survey, I heard about it, that around 40% developers say that they know where their data is, but the survey actually tells that they do not know where the data is actually stored when the model training and inference is happening. Then there is when you want to have a full control over your LLM deployments, you might want to use Kubernetes and the containers. And then there is option of edge deployments and then hybrid deployments. Hybrids are mostly used for RAGs. And again, then there comes the bare metal deployments, where you control everything, deploy your LLMs on your hardware and secure everything. I remember Shiva was talking something about deploying on Kubernetes. Would you like to add here?
Yeah, so of course, as we are seeing that companies are making that conscious decision on whether they want to host their data on their own private VPC network, or perhaps they want to use a cloud-based deployment. And of course, as we saw in the last talk, there is this black box not only just for the LLM, but if you're considering using a cloud-hosted solution, there is another black box with respect to what Vinodha mentioned about the data. So of course, you can use a bunch of open source technologies that you can leverage for hosting these LLMs directly on your data itself. For example, at our company, we host it's a database company, so we use cloud services to serve all of the database inside of the VPC network. And we now have started to use VLLM, which is a virtual LLM. It's a technology for model inferencing, and you can deploy VLLM on both Kubernetes and your bare metal containers as well. So in this case, we host it in the same VPC network so that the data sits very close to the LLM itself, and there is no issue of the data getting leaked. And similarly, with the advent of GPU support inside of Kubernetes, there are some inbuilt things such as the dynamic resource allocation, which is a feature of Kubernetes that's still in beta right now, but should be launched very soon, which allows you for being able to manage multiple GPU nodes inside of a Kubernetes cluster. So if you have probably models which are very large in size, you can very easily host them inside of these models. And then most of the GPUs today, like from NVIDIA, they have supported GPU drivers which allow for this easier transitioning, so that you're not just misusing a GPU. You can do things like GPU slicing. Of course, like these are discussions for more on how you can do GPU deployment more efficiently, but these are being used by companies right now. And of course, there are a lot of other open source projects that have come up. So for example, there's Vulkan that helps with better batch processing of your requests, so that you're not just making your GPU sit idle, because that can incur a lot of additional cost as well. So these are some of the security considerations that people are taking while they're deploying these solutions on top of Kubernetes in their own private networks.
So there are a lot of factors regarding the deployment, and it varies case to case. But here are some pros and cons. So if you wanna take screenshot, take a picture or something. Then once the model is deployed, the next step is to serve the model and let users use the model. And the one way to do that is this way. This is a general architecture of having a request from the users that goes through load balancer and then API gateways, which are there to manage multiple models that are being deployed. And there is model services actually, which are there with each model, and there are models deployment. So this looks like a pretty good architecture, but there are some security concerns. And how do we overcome that security concerns is AI gateways. And I know Rohit was writing a blog about AI gateways. So Rohit, why won't you add here?
Yeah, definitely. So, yeah. So, I guess I'm using this slide again from KCD UK. So, yeah, AI gateway is something everyone, you will see in the cloud native companies, like a lot of companies are writing about AI gateways. And this is kind of a diagram which I created, and it satisfies the needs, like what the high level kind of AI gateway will look like in the companies, which uses the Kubernetes workloads or any workloads they have for the AI, right? So there are different teams in the companies, right? So your workloads will be like your workloads is nothing but let's say you have some application running, right? So that has some workload. So it will route traffic through the API gateway, which is your center of centralization of everything. Then there is a security team. So security team is nothing but they will help you enforce policies and by the help of the API gateway. Similarly, gateway team is there, which specifies the routing of API specifications for the gateway, which will help to help API gateway to enforce security policies, manage traffic routing. Then it will also provide a unified interface for your workloads. So yeah, and also everything will be connected through the LLM. So your LLM can be connected, like it can be open source, cloud hosted, whatever. So you just can be connected using the APIs of LLM. So yeah, so gateway routes to various LLM providers using the same. So I showed one of the example. So to go in depth of this, I guess this kind of a diagram which can make more sense in the high level company oriented. So let's say user is interacting here with your client applications. It can be chatbot, yeah, and your AI powered SaaS platform or something. Then application need access to AI models like your LLMs or some LLMs or like any services you are using. So it will be providing direct access. Then there is a client application which sends request to the API gateway, which is shown there. And nothing but when you see how actually the security works here. So API gateway is something which will help in the security and traffic control. So it will help you with the authentication, rate limiting, routing. So similarly, there is the API manager who will help in the governance and control. So it will help for the policy enforcement as well as how you can how you can monitor the cost and usage for it. Similarly, of course, there is like different models and different APIs or different open source or cloud hosted models are there. So how to like enable like smooth integration between all of the AI providers, that can be done by the that can be done inside the API manager. So I just named as a vendor agnosticism, we say. Similarly, then there is the API AI gateway core we are saying. So it is nothing but it will help. It says like how developer and observability support is provided using the AI gateway. So developer portal, everyone knows about the platform engineering and stuff, right? So there is one API for everything, we say in the platform engineering. So similarly, there is a self-service for AI apps. So nothing but this developer portal will provide the self-service API access. So it will allow developers to integrate AI capabilities easily, and also it includes documentation, SDKs, code samples to speed up your development, and so platform teams can implement like let's say tool templates and everything for your entire teams. Similarly, for the API testing and observability is there, and so you can see the developer tooling is there. So developer tooling is nothing but this is how developers can use AI assistant to tools for integration with your system. And similarly, I just shown the GraphQL API development example, and then how integration support will be there. So backend services is something it will. So backend services is nothing but that's how your entire and like end user will receive the output. So whatever we did at the client application at the start, so similarly, so your backend services here will be your LLMs, it can be GPT, your Claude or something, right? And it can be machine learning models or database, right? So yeah, so moving forward, we talked about AI gateway, right? So there is also a lot of security risks associated with running model inferencing as well as model training. So let's first discuss like what are them for the model inferencing. I guess Shiva can.
Yeah, so I think that is a really great point about building these AI gateways. So what you have probably seen is that they are a natural progression of the API gateways that people were already building with all of the networking needs. It's just adding a layer on top for specifying the AI needs, and we'll have a bit of a more deeper dive into referent architectures being used in production, which we'll be showing you later in terms of how AI gateways work. But of course, they are designed in a way to mostly mitigate some of these security risks that you see. And these are not just for LLMs, but in general for any AI model that your company or you personally might be running. And I think like a lot of these were also covered in the first session during, so that was a really good session, by the way, if you haven't watched it. But a lot of them kind of break down into, I would say, three main categories. The first one is that as we know that a lot of these models are going to be storing some really highly specialized data, which you don't want to leak, because we are entrusting these models to be able to help users if you're building some sort of a support chatbot, let's say, and you are storing all of your private data from your company, which is proprietary to your company. And there will be some malicious actors who will try to use jailbreak techniques to be able to get into your system and get access to this personal data. So that's where there are techniques that today hackers or these malicious actors use, such as prompt injections, and they try to kind of reverse proxy their way into being able to move over the certain guardrails that your company might be setting in order to avoid from these situations to actually take place. But there will still be situations where your personal identifiable information might just get introduced because of certain hacks that the users are adding to these prompts, which essentially makes the LLM forget about the guardrails that have been set. So most of these things that you see, for example, the ability to leak the data through these inference logics, so that's primarily happening with the help of the prompt injections. But also, for example, if your LLM services are not authorized in the correct way, so that's where we spoke about the network and using the correct types of MTLS protocol and ensuring that you have proper security added in terms of the OAuth for these model inference endpoints. If that's not correctly identified, then the actors could get access to your critical endpoints that are serving these models, and they could just use that to generate the outputs and get access to your private information. So I think like most of these kind of break down into understanding how these LLMs work. And of course, probably the last one that I want to point out is supply chain, right? So we had a really great session yesterday which spoke about but when these LLMs are generating some sort of a code, you never know that what is the ground truth or the source of truth for these packages that it might be using. It could be possible that some of these LLMs might have been trained upon intentionally created data that is malicious, and perhaps the modern day tools like repository packages or system packages that get published, they might never be scanning them efficiently. And you end up using these particular tools inside of your code base, and you just create additional risk for your company, because now you have these unwanted packages that are existing inside of your entire code base, and you never know what might be the intention behind these particular packages. So the supply chain security is also something that we don't take into consideration that much, just because these are systems that we have never worked with before. And a lot of DevOps companies, SREs, are interacting with these particular tools for the first time. So as we'll dive deeper into the concept of zero trust security and how we can adapt them to LLMs, my panelists would be great to probably talk more about, as we now move away from what LLMs are, what are security risks, and then how we implement the core principles of zero trust security into LLMs.
Yeah, can you take over, like, what is zero trust at the first?
Sure. Just for the introduction, the zero trust, the baseline of the zero trust security is never trust, always verify. So it operates on the basis of monitoring and observing every request that is being generated or received or created within the application, or be it outside, coming from outside the application, or it could be for data as well. So the whole architecture is basically to not give access to unauthorized requests.
Yeah, thanks.
And Rohit would have the architecture.
Okay. Yeah, thanks for that. Like, so yeah, like continuing to that. So this is the architecture which you might have seen the same similar kind of a diagrams in by seeing the blocks or I guess NewsStack or InfoQ or companies writing about it. So this kind of a similar kind of a diagram by Equinox. So I have used that diagram. So zero trust security is something like it doesn't says like you have to directly give an access to anything. So that's what my panelist said, right? So it every time it requires to verify and authorize all connections and then only proceed, because let's say when human users or any connections are there in the network, then to your application or software program, it can be through the APIs or directly in any ways, right? So zero trust security system authenticates and authorizes any devices that then connections of your networking flows with requiring to dynamic policies. As you see, like PDP is there, right? PDP control plane, and you might have seen the PDP control plane in like all of the authorization tools available there, right? So dynamic policies and the security context, that's what said. So according to guided by NIST principles, so there are only 3 objectives for zero trust, which is nothing but continuous verification. Of course, you have to always verify all resources in your to make the secure environment. Similarly, minimize the impact there is. So reduce whatever consequences might occur. So it can be external or internal, whatever. Then you have to you can automate context for all of your resources. So it can be done by checking the behavioral data and based on the reliable results in the future, right? So there are some kind of principles in the zero trust which every zero trust architecture follows. First one we talked about is the continuous verification. Then second is the risk-based conditional access. So you have to check when the risk changes. So you have to achieve continual verification while maintaining whatever proactive users are there, right? Similarly, segmentation you might have heard about. So what segmentation does is, like, one of the example we can talk about is like, let's say whenever segmentation is put into your architecture, then whatever thing your network you are creating on your data center, using micro segmentation, you can scatter it to the dozens of your different zones. So whenever any external person wants to enter into a system, then they can't get directly access because they don't have access to all of the zones. So they have to our system will verify every zones, and then only they can enter into it. Similarly, least privilege is there, which is like you have to provide least privilege to all of the API accesses or person access will be there. So it can be done using authorization, proper authorization and all, and working towards the observability and monitoring as shown there. And as you can see in the diagram, so authorized one is like shown as untrusted because you can't trust anyone. You have to first verify if they have the access, and then only they can provide access to the particular part of the your resource, not like entirely everything. So yeah, that's what is zero trust architecture in the high level. We can go in depth, but we have to focus more on the LLM side now. So one of the part I would also like to mention is like ZTNA. So it's like zero trust network access, and it is popular term technology used for the identity-based authentication. It allows to keep your network allocation of your IP address hidden with providing entire access. So yeah, you can learn about it. It is really amazing. And so going forward, this is kind of a zero trust security you can maintain in the AI or like let's say LLMs. It is similar to what I showed. So you can see like there is a zero trust authentication, and similarly authorization will be done on the basis of attribute. So you can directly provide on the different roles have like different accesses to enter system, but on the rather you can provide some kind of attribute access. So depending on what kind of access they have, limit their access kind of thing. So if they have the access, then again you have to in the machine learning when you are training the models, that is different. Then when you are maintaining the data pipeline, then that is different. Similarly, when there is an inferencing and output validation, every step should have some kind of a verification needed. Otherwise, you can't directly provide access to entire thing once authorization is done. Every time you will see like after in the data pipeline also we are asking for policy encryption, privacy encryption, and then in the model training we are also checking like if that model training is ethical. If it is good, then bias evaluation will be done, and if it's good, then they can move forward. Similarly, if everything is done and still there is any problems in the security operations, then it will again go to the risk evaluation and check up for the authorization, and they can't directly get into your system and for the when you are training the machine learning models or LLMs, right? So this kind of security we can maintain in the whatever open source models you are using on your system or in the companies, because it's really needed, because today like AI guardrails and safeguarding of AI is really important matter, and lot of popular conferences and companies are discussing about it. So yeah, I would really encourage you to learn more about it. Yeah. I have gone through one of the recent content created by OWASP about they created like top 10 security OWASP policies rules you can check for the LLM applications. This is for the 2025. So I would like my panelists to continue about it and share insights about it. Yeah.
Yeah, sure. So OWASP is the standard for security risks and for application security, and these are some of the security risks it has come up with as their top 10 for 2025. I would really like to cover this in depth, but I think we are on time crunch, and I would just summarize this up over here. So to summarize this, it's basically talks about all the possible security risks are there when the AI workloads are deployed. So there is prompt injection, like manipulating the model's behavior by injecting malicious prompts. There's supply chain security, and there is then disclosure of the sensitive information that could come from the prompts, system prompts itself, or the training data that has been fed to the model. Then there is improper output handling, and there is also a false information thing that I've personally observed when I was researching about something. It was just GPT to be named here. It just invented the citations itself. The citations did not exist. So that's just one example, but there is a lot of misinformation that LLMs outputs, and there should be fact checks implemented, and the security measures to take to prevent and mitigate the security risks are basically revolves around implementing proper authentication, implementing proper strict input validation, and updating third-party softwares that are being used when deploying these workloads. And there are more that Shivai wanted to talk, and I'll pass on to him.
Yeah, so since we are on time crunch, I'll probably keep this very short, but I just want to highlight basically, like as I mentioned, that my company implemented most of these OWASP mechanisms for designing our own AI gateway. So as we kind of conclude the session, I'll just quickly go over some of these measurements, and probably Rohit, we can skip over some of the open source part. We can talk about those, and I'll probably also cover the reference architecture. Sure. So, of course, primarily, as we mentioned, that some of the key decisions that are also spoken by the OWASP for LLM applications really just kind of fine-tune in terms of 5 main categories. So the first one is the prompt injection, which, as you mentioned, that the malicious actors can go ahead and try to add some adjustments to the input prompts, which essentially tricks the LLM to be able to then respond to queries which it shouldn't, which are typically set as guardrails when you're designing your entire LLM gateway, right? So a lot of different types of open source technologies like Rebuff are basically being used to identify these type of prompt injections and prevent them from happening. The other one that I'll probably also cover is like runtime security. So this is more on the network side, that ensuring that you have proper empty list support if you're passing through your request through your network prompts. And one of the tools that you can use is like Burp GPT, which is still relatively new. And just want to make sure that we are clear that these particular tools are still relatively new, because we have seen that the rise of open source technologies that help prevent a lot of these have just been around for the last 1.5 to 2 years. So as all of these LLMs will also expand, as the use cases will expand, the adoption of better open source technologies will also improve. So we just want to ensure that that's very clear. Now, apart from that, another important aspect is model artifacts. Similar to how we use containerization technologies and signing of our containers in proper, OCI artifacts. Today, a lot of work behind the CNCF is also happening on making ML models also OCI compliant, such that, because we know that all these model architectures are a bit different than your typical container architectures. So proper signing of these images, of the weights, is also equally important to ensure that we are maintaining the integrity of these data models and they are not being used by some bad actors. And then, of course, we can use the same type of freeback or RBAC techniques that we typically use for our software applications, but we can use them for these GenAI applications as well, which essentially means that we are providing attribute access only for specialized roles, such that, for example, if there is a chatbot that you have created for your support, only the people who have access to certain information can access that. So we are using those same principles, but we are applying them to the LLM-based applications. And finally, of course, PII is very important. It's probably the most important thing and the biggest security concern when we're dealing with LLMs. Now, typically when you're designing these AI gateways, during the time when you are storing the information, you can use open source technologies like Llama Guard, which is one of the most widely used models today, provided by Llama, by the Llama set of open source models by Meta. And that allows you to, from a security perspective, to see like if there is any prompts that is requesting for some private information, then it essentially prevents it. And you can use it in conjunction with open source technology like LangFuse, which anonymizes your data as well. So So these are some of the other open source models that we don't have enough time to cover, but we can proceed to the architecture.
You can, we will share the slides, so you can just check it afterwards. So this is like KI Gateway, like newly donated project in the CNCF about Kubernetes Gateway. So you can also check it about, sorry, API Gateway, sorry. Yeah. So yeah, Shiva, you can.
Yeah. So just to kind of finish off what we have kind of covered in this entire panel, more of a informational session. But the idea over here is that we want to enclose all of your typical architectures by having the same sort of security principles. So having proper access via RBAC control or having proper authentication with the help of API keys. Now here what you're seeing is that as soon as we get any request or response for your GenAI application, first of all ensuring that it is OpenAI compliant, because that kind of forms as the basis of your LLM applications. Then we want to add the rate limiting, caching. So these are, of course, all of the things that we covered in the AI gateway. The core things that we want to ensure and want to highlight specifically are the guardrails and the hallucination detection, right? So the guardrails are where we talk about things such as the personal identifiable information and prompt injection implementation techniques. So here you'll be using models like Llama Guard or the Llama 3 Guard, which are integral for being able to persist with the personal identifiable information. And then hallucination is also, of course, as we mentioned, that you can use specialized open source models for being able to automatically detect the hallucinations that are taking place. So probably, Rohit, if you can move to the next slide. So here is pretty much what we have covered in terms of better understanding. So you'll have a specialized requirements on just the safety and compliance, which are the two things that you will implement inside of your guardrails. And finally, this is what we have at our own company, where you can see that there's a control plane, which is the database UI, which any person will use. Then we have a data plane, which has all of the database being stored in that same VPC network. And in that same VPC network, in your container, we are running the separate VLLM service, which is an open source technology for serving the LLMs. And then you have your AI gateway, which does all of its role of routing your network and the observability related to all of your requests that are being handled. So here, from a security perspective, what you're seeing is that the LLM is being hosted in the same VPC network as your data. So that means that you're not relying on external requests and making your data being, adversarial to an external request getting attacked. At the same time, you're also getting proper support with using JWT tokens or your API gateway, which will have proper authentication baked in. And then finally, all of this is still being enclosed by proper MTLS network policies that you will have in a traditional cloud application as well. So these are some of the best practices that you can employ in terms of a reference architecture. But yeah, I think we are pretty much on time.
Yeah, sure. Like, if you would like to share any use case, or like we can just sum up.
I think.
Yeah.
I think we can have questions if we have any.
Okay.
If there are any questions, we can take them. There's just room for one. I'm really sorry. So
Sorry for that.
First is going to get a...
Thank you. Thank you for the talk. So I'm coming from the point of view that I'm working on hardware for AI, and I was wondering, in this zero trust architecture, what do you see the role of hardware, if it has any, and like current GPU, both in terms of hardware and in terms of driver and so on, are there like some features right now that helps with that and that critical in your point of view? And do you see maybe gaps in it or things that could help with that security aspect?
Yeah, that's a really good question. So in terms of the core hardware that you'll typically use, there are existing technologies that I already mentioned, such as the VLLM, which will be used for the inferencing and the batch processing of all these requests. At the core hardware level itself, of course, like there is no native security implementation that you get, but when you are using these alongside, like let's say, so one of the use cases that we have is that, for instance, you talk about containers, right? So containers come in their own enclosed securities. We can say that they are these secure platforms. Now, the way that at least we are running the GPU inference service is that we use the Visor. If you're already, I'm not sure if you're aware of Visor. So that enables additional security mechanisms such that your the AI workload that you're running sits separately from the business logic of your application. So that again adds better privacy for your application. And then you can very easily then use this with your GPU inferencing that you're running on top of a Kubernetes cluster or a containerized environment, which have their own security measures, which can help mitigate some of these risks that your core the devices might have, because these devices will also have their own IP address or perhaps some sort of address that uniquely identifies them, which can be guarded by technologies like VLLM.